All right, your warm-up says to write the equation of a circle with center at 0, 0 and radius 3. How do I do that?
X squared plus y squared.
3 squared, which is 9. Good. Pretty simple. What are your questions on the warm-up? All right, today we are doing section 10.4. It's all about ellipses. Ellipses are more challenging than circles, so make sure that you are listening today. They're like elongated circles, not half circles. Right. Similar to an oval. You know the orbit of the planets? Have you seen pictures of those? Those are ellipses. Here is the formal definition of an ellipse. An ellipse is a set of all points P such that the sum of the distance between P and the two distinct fixed points called the foci is a constant. So that's basically saying that if you took two tacks, stuck them somewhere, and had string attached to it, and that string was a certain length, if you traced around it with a pencil, just like you see on the board, it would form an ellipse. So it's all the points that are the same distance from these 2 points when you add them. All right, so let's say this was like 5 and 15. The string would be, 20 inches or whatever. All the points 20 inches from those 2 points would be on this ellipse. It's not super important that you understand that definition, but that is how you would draw an ellipse if you had 2 nails, a piece of string, and a pencil, and you wanted a perfect ellipse. Any questions on what an ellipse is? A few of you said other words like ovals or elongated circles. So you have an understanding of the basic shape of an ellipse, but that's the formal definition of an ellipse. You should write all of this. This is the most important information presented today. So these first 2 things that you see are the standard form equations for an ellipse. You need to know that A is always bigger than B. So if the larger number is under your x squared term, you'll have a horizontal major axis. If the larger number is under your y squared term, it's a vertical major axis. So if it's under the x term, it will look like this. If it's under the y term, it should look like this. All right, and then the rest is just how to find the vertices, the co-vertices, and then it is very important that you have this down as well. This is how to find the foci. That small little y is part of this graph. Sorry, it's really close. This is just a squared minus b squared equals your c squared. And then the c is where your foci are located, and those are always inside your ellipse along your major axis. So the same line that your vertices are on. If you're talking about one, it's called a focus. If you're talking about both of them, they're called foci. Kind of a weird pluralization, but that's what those words mean. We'll talk a little bit more about what it means when I say vertices and co-vertices. I have a more detailed picture on the next slide, but for right now, I would definitely write down everything in that table, and then you need to know the c squared equals a squared minus b squared part as well. Here's that more detailed photo I was telling you about. So here is an ellipse. You'll notice that one of the axes is always longer than the other, and we call this the major axis. The endpoints of the major axis, we call these the vertices, or the 2 vertexes, if you would like to call them that. And then in the other direction, this will be a shorter distance. We call these the co-vertices. So the co-vertices are going the shorter way. The vertices are going the longer way. Center is obviously in the center, and then you always need to also locate the 2 focuses or foci, as they say. Any questions?
Yeah, what you said was
The co-vertices, they're on the end of your minor axis. So the A is going to tell you how far to go out for your vertices. The B is going to tell you how far to go out for your co-vertices, and then you use C to find the foci. Once you have those things, then you can graph it. Questions? All right, I'm going to show you a few examples. I do not want you to write them down. I just want you to watch and soak them all in. Okay, so I was just sort of hinting at why A and B are so important to us. The first thing you want to do is figure out which one's bigger. The bigger one we always call A. So whatever is in the A position, if it's under the X, you're going to have a horizontal major axis. You go out in A directions from the center. You go out in, you guys are distracting me. A units from the center in the horizontal direction. And then in the opposite direction, you go out B units. And then you graph it. So here's an example for you. You can see that the larger number is under the X term. Everybody see that? Yes. That's how we know we're going to have a horizontal major axis. Now, what would you square to get 16? 4. So you need to go 4 in each direction horizontally. What would you square to get 9? 3. So in the other direction, which would be up and down from the center, that's at 0, 0, you would go 3. Then you would draw that ellipse. We also need to locate the foci. You do that by doing a squared minus b squared equals c squared. So I would have 16 minus 9 equals c squared. When you solve for c, you'd get the square root of 7. That's about 2.6 in either direction in the same way that you graphed the vertices. So if they're horizontal, your foci should also be in the horizontal direction. Any questions so far on this example? So now, again, you don't need to write this down. You can just sort of watch and soak it in. I'm going to look at one where the A term is under our Y. So when the A term is under your Y, you're going to have a vertical major axis. And then, of course, those are both just going to give you where your vertices are located and your co-vertices are located. Here's the one I want to look at, though. So now the 16 is actually under the Y, not the X. That means that the major axis is going to be vertical. So I'm going to go up and down now the 4 units instead of left and right the 4 units. And then, of course, again, we got 3 here in order to get 9 when you squared it. Since that's under the X now, that's how much you go left and right from your center. And then you'll still get the same value for C as we did on the last one. The only difference is now, since it's a vertical major axis, you're going up and down that many units. Questions on this so far? All right, here's the first example that I want you to actually graph with me. Yes, I heard someone say vertical. How do you know it's vertical? Yeah, the larger number is under the Y. That means my longer axis is going to be up and down. So this is going to be vertical. So your vertices are going to be up 3, that's the point 0, 3, and down 3, that's the point 0, negative 3. So you can graph those. Co-vertices are going to be where? 2. Yeah, 2 in either direction, left or right from the center. So I will have a co-vertice at 2, 0, and one at negative 2, 0. And then you always do a squared minus b squared equals your c squared to find the location of your foci. So 9 minus 4, take the square root, that's going to be 5. So square root of 5. Since your vertices, you went up and down, for the focus you have to go up and down as well. So I'll have one of my focus at 0, 2.2, the other one at 0, negative 2.2. Now, one thing I want to point out, do not get lazy with these. I know a lot of people will write plus or minus 3, plus or minus 2, plus or minus 2.2. I need to know if it's your x coordinates or your y coordinates that you're talking about. So if you want to write the ordered pair 0, comma, plus or minus 3, I will accept that. Or plus or minus 2, comma, 0. But I need to know if you're talking about x coordinates or y coordinates. So don't just write the numbers, write the 0 as well. Write them as ordered pairs. Any questions on number 1? Here's number 2. Which way will this one be going? Horizontal, because the larger number is under my x squared term. The square root of 9 is 3, so you will have a vertex to the right 3 from your center and to the left 3 of your center. So those are the ordered pairs 3, 0, and negative 3, 0. Square root of 1 is 1, so you'll have covertices up 1 and down 1. Once you have those, you can graph it and then find your foci. Anyone know, just looking at it, where it will be? 9 minus 1, take the square root. Square root of 8. Type that into your calculators to get a decimal approximation. It's right around 2.8. Again, since our major axis is horizontal, you need to go left and right for these as well. What are your questions? Here's number 3. Oh, back to number 2. Oh, that's not number 2. There you go. Sorry, technical difficulty. Vertical, how do you know vertical? Yes, the bigger number is under the y. So when I am going 6 units, A is obviously 6 because you'd square 6 to get 36. When you're graphing that, to make sure you're going up and down. So that's the point 0, 6 and 0, negative 6. Then what? The covertices are 3 units. Good, 3 units to the left and to the right. So those are the ordered pairs 3, 0 and negative 3, 0. Go ahead and connect all those. You still need to locate your foci, so I'm going to do 36 minus 9. Take the square root. I get square root 27 when you type that into the calculator. It's about 5.2. So you're going to go up 5.2 units, down 5.2 units, and you get the ordered pairs showed on the board. Which direction? Horizontal, because the larger number is under my x squared term. So you need to figure out, well, what did you square to get 49? That would be 7. So I am going in the horizontal direction, 7 units. So that gives me vertices at 7, 0 and negative 7, 0. I am counting by 2's here just to save some space. So if you're not sure why our graphs aren't matching up, it's just because I'm counting a little different. Then what? Where are my covertices? Yeah, up 4 and down 4. So those are the ordered pairs 0, 4, and 0, negative 4. Draw on your ellipse. Next, we're going to do a squared minus b squared equals c squared to find the location of our foci. They are at square root 33. That's about 5.7, so you go 5.7 to the right, 5.7 to the left, and you get those 2 ordered pairs shown on the board. And there they are on your graph. All right, before we do the equation examples, I just want to show you a little something extra on the board. So there are some examples or some problems in your homework that will look like this. Now, in both of our standard forms, what did it have to be equal to? 1. This is not equal to 1. How could I turn this into a 1? Yeah, divided by 100. You can divide every term by 100. Then you would simplify the fraction. So now I have x squared over 25. I have y squared over 100, and that equals 1. You can graph this. You probably cannot graph this. Okay, so just be aware, if it's not equal to 1, this is the way you make it equal to 1. Any questions on those? All right, let's look at number 5. Okay, the tricky part here is deciding whether your a should go under the x squared or under the y squared. So you need to decide, well, which way did they go to graph this vertex? Okay, so if you start at 0, 0, how would you get to the point 3, 0? You go right 3, right? So this is a horizontal?
Yes.
Yes. So where does the A need to go? Under the X. Good. So when you're writing this equation, that 3 squared goes under the X, and the 1 squared goes under the Y. And then, of course, just square those, and that's your answer. So this does not automatically go under your x squared term. So we'll look at somewhere it goes under the y squared term. So just please be aware of that. A lot of students just want to stick it right under the x squared, stick this one under the y squared. It doesn't work like that. You have to decide, well, which way is the vertex compared to the center. If it's side to side, then it looks like this. If it's up and down, though, then you got to flip-flop the A's and the B's. Any questions? All right, here's number 6. Again, the easiest way to do it is think of starting at the center, 0, 0. How is this point related to the 0, 0? Yeah, it's down 4, which means you also have one up 4. So it doesn't really matter if you're going up or down. What matters is that you know that that's a horizontal major axis. So my A is 4. Oh, did I just say horizontal? Sorry, I meant vertical, of course. So since you're going up and down, it's vertical. Again, signs don't matter here, because if you have a vertex at 0, -4, you also have one at 0, +4. So don't get hung up on the negative. What's more important is, did you go side to side or did you go up or down? And this one we went up or down, so it's a vertical major axis. So where does the A go? Under the Y. And you got to square it. Square the 3. Put it under the X. So this is our equation. What are your questions? All right, 2 more examples. What's my A value? 4, good. Now, we just have to decide if it's horizontal or vertical. Horizontal, because you'd have to go left 4 to get to this vertices, right? And then you'd also have one to the right 4. So that's a horizontal major axis. So where does the A go? Under the X, good. And of course square it, also square the 2. When you simplify those, you get x squared over 16 plus y squared over 4. And an ellipsis that always equals 1. Questions? All right, last one for the day. All right, I know that A is 5. That's not really the tricky part. The tricky part is deciding if it's going to be vertical with the A under the y squared or horizontal with the A under the x squared. How's this one? Vertical, yes, because this point, your vertex, is above the center. So you had to go up, which means you also have one down. This is going to be vertical. B is 2. When it's vertical, your larger one goes under your y squared, the smaller one goes under your x squared. Square those, and you get that equation shown. What questions do you guys have? All right, here is your homework. Notice I added 2 problems. Most of this is graphing. These are writing the equations, so I want to make sure you get a little bit of practice with this. Tomorrow we are doing word problem day. Friday is a work day. Monday is a review day. Tuesday is a quiz day.